Good morning. This is the first course in ICEM Hexa. ICEM is a pre-processing software for CFD analysis from ANSYS. It's one of the most powerful pre-processing softwares out there in the market today. Being powerful, it's also very difficult to learn on your own. Its difficulty stems from the fact that So we start with the creation of the cylinder, the geometry of the cylinder. We go to geometry tab and here create surface. We click on it. A new sub menu opens. Here we click on the standard surface, standard shapes, because a cylinder is pretty much standard. So and then we select this cylinder here. We specify the radii as 1 on each of the face of the cylinder, and we have to select 2 axis points. So we click on the selection tool here, and here a new menu opens, a selection menu. Here, if you see here, the XY option is switched on, it's toggled on. So this will allow us to select the point on the XY plane only, because the XZ option and the YZ option have been toggled off. They are dim, while the XY option is brighter. So this will allow to select the location on XY plane only. And this option we can here the toggle show location. We click on it. So now that when we select location, its indices will be shown to us. It's the value of the coordinates, the XYZ coordinates will be shown to us. So we have selected the allow on XY plane selection toggle, and we have toggled also the show location option. So we select here the first point, which say minus 0.660, and this seems quite near, so we go ahead and still very near. So so this looks like preferably a reasonable cylinder. Approximately 6 is the axis length, and 1 is the length of each of the 2 radii. So we middle click the mouse and to confirm selection, and then we say apply. So this is our cylinder. This is a cylinder, and so we play dismiss here, and then we go to geometry. Here we can see the curves, the points. We switch on the points, so this shows the points here, and we can show large points as well. So the points visual depiction becomes larger. The curves and the surfaces. The surfaces are like, we can change the display to solid. This looks little more engrossing, and so this is how the geometry has been created here. Next, we move on to creation of parts. Now, the creation of parts is important in ICM CFD because the boundary conditions in ICM CFD are assigned only on parts. They are not assigned on geometrical entities directly. A boundary condition can be assigned on a geometrical entity only if that geometrical entity is contained in a part. So that's the important point here. And secondly, this is a 3D geometry, so it's obvious that the boundary conditions will be applied on surfaces. So it's very important that we create a part of each of the 3 surfaces. There are 3 surfaces here. One is the surface on the curve, the lateral surface on this side. Second is the lateral surface on this end. The third is the curved surface area of the cylinder. So we will create a part of each of the surface, because the boundary conditions are applied only on parts. So we right click on parts on the display tree, create part, and then say inlet, and then entities. Here again a selection tool, selection menu opens. We unselect the selection of points because we don't want to select points. We unselect the selection of curves because we don't want to select curves. We unselect the selection of bodies. So that's the only thing remaining is surface. So now the cursor will select only surface. So this makes the selection easier. This is an important trick in ICM to help selection easier. And then this first button here, it allows to toggle between selection and uh, dynamic and viewing, dynamic viewing. So if we toggle here, then we can use the cursor to move the body or to play with the body, and then we know that this is the inlet, so we again toggle back here. Now the cursor will select, it won't move the body. So we select inlet here, right click, middle click to confirm, I'm sorry, middle click to confirm, and then say apply. So this becomes an inlet. Similarly, we define an outlet which then we selection of surfaces is only enabled. Select this surface, middle click, and apply. So, and then the wall. So the wall is this curved surface, middle click, and apply. So this is how we have created three parts for three surfaces, one part for each surface. And then so this is for boundary condition. Now it is a good practice to keep all the curves in one part and all the points in one part. It's a good practice. So we'll create a part called curve. So we will toggle the selection of curves on and toggle the selection of surfaces off. So it will now select only curves. So this curve we have selected, or instead of selecting all the curves individually, we can go to this option and it will select all appropriate objects, and all the appropriate objects are curves here because only that selection is toggled on. So we'll press this key and all appropriate curves, all appropriate objects, namely curves in this case, will be selected. So apply, and then again points. So we toggle the selection of points on, then select. So right now we created three surface parts, inlet, outlet, and wall, and one part containing all the curves and one part containing points. So this is how we define the parts. We can check the check the info on any of the parts. We can change its color. We can rename it if we want. We can rename it. And that's all for the parts creation. Now we move on to the creation of the mesh. So in hexahedral meshing, the ICM starts by creating a block. It's like a sculpture trying to create a figure from a statue. It's like a sculpture trying to create a statue. So that's original block of stone. In case of sculpture, here it's called a block. So we initialize a block by clicking on this tab here and create block. And the thing to note here is that it gives us the option to create a block in any part we want. So the thing is that the block should be in a different part than the geometrical entities. These parts here, they contain geometrical entities like surfaces, points, curves, but the block should be in a different part altogether. So we can create a new part itself and name it as like fluid. This part does not exist right now, but when we initialize the block, the part will be created and the block will be transferred to that part. So we scroll down here and we select 3D bounding box because this is a 3D figure, and and for entities we don't select any entities here. This is because we want the block to cover the whole of geometry. So in that case, we should not select any entities if we want the block to cover the whole of geometry. And then say apply. So a block has been created here. So this block is composed of edges. These black are edges, faces. These are the faces, and of course the block itself. So after the creation of the block, we do the association. In ICM, the block has to capture the shape of the geometry, and it is also to be associated with the geometry, because the mesh is created on the block. It's not created on the geometry. It's created on the block. So the block has to associate the geometry and capture its shape, so that the mesh comes out of the same shape as the geometry. That's the tricky part of ICM, making the block capture the shape of the geometry. And that's why I began with a very simple geometry here of that of a cylinder. So we begin our association by clicking on blocking and then associate edge to curve. We click on edge and we click on the edge on one of the ends, and then we select curves here. Then we build click and then say apply. Similarly, for the other end, we select edge here. You see there are 4 edges which are being associated with a single curve. So that is allowed in ICM. You can select multiple edges and associate with one curve, or you can select one edge and you associate with multiple curves, and you can select one edge and associate with one curve. Everything, all the permutation and combination of edge and curves association is allowed here. And this dismiss here. So the edges have been associated with the curves, and you can do one more thing here. You can do the edges after association, they turn green in color, and I have switched on the vertices and their display, and the display is projection type. So it shows what the vertices here, these vertices, what they will be projected to. Projection means the entity will physically move on the block. It will move towards the blocking entity. The geometrical entity will physically move towards the blocking entity on to which it is associated. So I will go here, associate, and do project vertices, snap project vertices, all visible, then say apply. So all the vertices here which are associated, they will physically move to the blocking entity to which they are associated. So I place apply here. You see the vertices here have moved to the curves to which they were associated. So our blocking is complete for a simple geometry. Now I wish to denote the mesh on the geometrical on this block. So I go to mesh and then say part mesh setup. This part mesh setup allows us to set the mesh on a geometrical entity part-wise. So you see all the parts have been enumerated here, and we can set the mesh on all the parts individually. For this, we will set the mesh only on the surface parts. Say I will maximum size of the element on inlet should be like 5, outlet should also be 5, and the wall should also be 5. Please keep in mind I am selecting only the surface parts. Height of the first layer on this part should be 1. Height ratio is like 1.1. Then say apply and dismiss. So the parts have been given a certain mesh size, but please keep in mind this mesh size is still not transferred to the block. It's still in the geometry itself. It's not transferred to the block. To check that, I can do an edges and show counts. So it will show only 2 counts, which is like the simplest 2 nodes at each of the vertices. It's not showing any more counts. So I switch off the counts So there is no counts. The mesh has not been the meshing parameters have not yet been transferred to the block. To do in order to do that, to transfer the meshing parameters to the block, I go to blocking, pre-mesh parameters, and then update sizes method, update all, then say apply. So you see here, when I pressed apply, it's giving nodes is 12, quartz is 10, hexas is 2. It seems that the mesh size which we gave was too large, So a good mesh is not expected right now. If I press pre-mesh here, it gives a very bad quality mesh. The mesh size I gave was too large. So it's like 3 counts here. This is the mesh I got because the element size was too large. So I can do one thing. I can go to blocking. I can again go to pre-mesh parameters and select scale sizes, and I can give a factor of say 5. A factor more than 1 will make the mesh finer, or I can say give it 3. Let's start with 3. A factor is more than 1 will make the mesh finer. So I do apply. Then yes, mesh is currently out of date. Compute, yes. Then it becomes finer. If I give like again 3 and then say apply, it becomes even finer by a factor of 3. So this is how you play along with these two factors. So our mesh is ready by the simplest mesh is ready for this. We can make this mesh better. There are two things we can do. If you see here, here the angles of this element are not good. They're not, the internal angle here is very less, which is not good for analysis. I mean, the internal angle should be as orthogonal as possible. And secondly, if you see here, so the quality is not good because of the internal angles here. And secondly, the flow physics here is that of fluid flowing in this cylinder. So as a fluid flows, it will form boundary layers near the wall. All along it will form boundary layers. Now at the boundary layers, the gradients are very high compared to the mainstream. So to capture the gradients in the boundary layer, we need finer mesh near the boundary compared to the center line. So we need finer mesh towards the boundary, and we need to improve the quality of certain elements here. We can visualize the quality using this pre-mesh quality histogram, and you say angle, you select angle and you say apply. So you see some of the elements here have very less angle, less than even 9 degrees, and they are like 88 such elements, which is not good at all. So I will try to improve the quality of this mesh now. This will be done by using the function of ogrid. So I go to into we want to improve the quality of this mesh, as well as we want to simulate the boundary layer. We want to be able to simulate the boundary layer. So we go to that can be made possible by the use of ogrid. So we go to blocking here, and then we split block. We select ogrid block, and then let's switch off the pre-mesh first for ease of visual display. And then we select box, we select this block here, and we select faces, select the two end faces, the curved, the lateral surfaces, and then we middle click to confirm the selection and apply. So an ogrid has been created. ICEM CFD gives you the option to tinker with the node distribution on an individual edge as well, not just the part. As we saw here, we did the part mesh setup. We can tinker the node distribution on individual edges as well. So let's change the node distribution here. We go to blocking, this pre-mesh parameters here, and then select here meshing parameters, edge parameters, and select the edge here, select here. So we will check this copy parameters to all parallel edges. So all these red parallel edges will also be copied. And we will select the number of nodes, say 16. And we don't want it to be uniform. We want to be a finer mesh near the wall and a coarser mesh away from the wall to simulate the boundary layer. So we select different meshing law, let's say from graphs. So we'll select the function as S-curve. If we do an S-curve here, so this is the this is giving a finer mesh here and a coarser mesh here. The dots here show the apparent bunching, the potential bunching when we apply this. So we can say done and say apply. Say dismiss. Then we again go for pre-mesh. Oops. So it has done a reverse. We see a reverse mesh here. I mean it should be finer near the wall and coarser near the center line, but it's reversed. So we will again change it. We'll change it here. We'll select here, and then we will do here function reverse x about x, and then say done, and then say apply, dismiss. Then we do pre-mesh here. You see we got it. Our mesh is much finer near the walls and much coarser here. Similarly here, and if we do a quality check, we can see angles, select criterion angle, select apply. So we see the quality is much better than. I would suggest you to before I close this lecture, I would suggest you to go here and change the meshing laws and see how the mesh distribution changes. Which distribution captures the mesh as good as you want it to. You can select this edge here and then play with the meshing laws here to see what is the good meshing law for this. Can we improve it further? Thank you.